Hey folks, I'm sorry I'm unable to be here today, but I'm going to record this lesson to help you out with day 3 in your notes of simplifying radicals. I will check your day 2 homework the next time I see you. Right now we're on page 10. Please make sure you have a calculator ready. Today we're going to still continue to simplify radicals, but we're doing this with fractions. This is the division property of square roots, which says this: if you have a fraction underneath a square root, you can simplify it by square rooting the numerator and square rooting the denominator of that fraction. So you're going to give the numerator its own radical, you're going to give the denominator its own radical as well. What it also tells you is you can simplify the fraction first underneath one radical before you split it up. So let's take a look at the two examples that we have here on the page. Does 36 and 49, do they simplify? The answer is they do not. So we're going to square root the numerator separately than the denominator. So we're going to do the square root of the numerator, square root of 36, divided by the square root of 49. 36 is a perfect square, so when we square root it, it is a whole number. The square root of 36 becomes a 6 in the numerator. And 49 is a whole number. When you square root it, it becomes a 7. Since 6/7 doesn't reduce, we are done with this exercise. Look at exercise 2, or the example underneath. Here you have 8x to the third over 50x. Does the fraction 8 over 50 reduce? Yes. Do the powers reduce? Remember, when you reduce power, we ask, where is there more and how many more? So 8 and 50, 2 goes into 8 4 times, and 2 goes into 50 25 times. Where are there more x's? There's 3 x's in the top and 1 on the bottom. There are 2 more x's in the top. Now that you have simplified the radical at the beginning, we probably won't have to simplify it at the end of this exercise. Give the numerator its own radical, the square root of 4x squared divided by the square root of 25. Since 4 is a perfect square, the square root of 4 becomes the 2 outside the radical, and the square root of x squared becomes an x. So the square root of 4 becomes the 2, square root of x squared becomes the x, and the square root of 25 becomes the 5 in the denominator. Nothing simplifies. Let's look at our next section. It says divide and simplify. Can you reduce 16 over 25? I don't believe so. So we're going to separate this into 2 radicals, the square root of the numerator and the square root of the denominator. So we're going to put the 16 in the top and a 25 at the bottom. The square root of 16 is equal to 4, and the square root of 25 is equal to 5. So 4/5 would be our finished answer. Looking at number 2, we have a number on the outside. When we have a number on the outside, you just leave it alone. 100 over 729. One way you can check to see if this simplifies, just do the ABC key, and it tells you it does not simplify. So we're going to separate it, the square root of the top divided by the square root of the bottom of that fraction. Both of these numbers are perfect squares, and you can use your calculator to figure that out. Bring down your negative 4. The square root of 100 is 10. The square root of 729 is 27. Let's see how you do that. You can do second and then the radical key, and 729, close the parenthesis, and that is a 27. The final thing you're going to do is, since everything's on the outside, you're going to multiply negative 4 times 10 over 27. When you multiply fractions, you multiply numerators to numerators and denominators to denominators. Negative 40 divided by 27. I snuck this 1 underneath the negative 4 because negative 4 is a whole number, negative 4 over 1. Technically, it's an integer. Look at exercise 3. This one I want you to analyze a little bit more. Although I do see some things do simplify, I might leave them alone, I might not. 64 is a perfect square, so I think it didn't simplify anyway, the 3 and the 64. I think we're good to go. I don't think that does anything, but we could simplify this, so we're going to simplify the x's. So let's simplify this fraction. I have a 3, an x, and a 64 on the bottom of our giant fraction in our radical. So the 3/64, that didn't simplify, but the powers of x, they did. We're going to square root the top, the square root of 3x. We're going to square root the bottom, the square root of 64. We're going to circle the square root of 64. That simplifies to become an 8. And the square root of 3x, that just stays the same. This is our final answer. Forgot to put a box on final answer for this one. Alright, there is a special note at the bottom on top of exercise 4. Excuse me. We'll take a look at that in a second. What is that special note for? It's probably to take a look at what you may or may not be able to simplify at the beginning of each of the exercise. So we got 11 on the outside. We're going to keep the 11 on the outside. The square root of 49, 8 to the 5th, over 4, 8 to the 3rd. Our special note is you always want to look for perfect squares. Look for squares. Look for perfect squares. Perfect squares could be that list of numbers we read on the side of our page. Perfect squares could also be even exponent powers. Excuse me. Even exponent powers. So let's take a look. The 49 and the 4, those are both numbers that are perfect squares. Neither of these are even, but when you simplify them, there's 2 more in the top, and it would be an even power. So I think everything inside the radical will become a perfect square. The 49 stays the same. The 4 stays the same. Where are there more a's in the top, and how many more? 2 of them. I'm going to circle all of my perfect squares when they simplify, like we always do. So the 11 stays on the outside. We're going to square root the 49, square root the a squared, and square root the 4 separately in the numerators and the denominator. Circle each piece that simplifies. The 11, again, stays on the outside. The square root of 49 is a 7 in the numerator. The square root of a squared is an a. And the square root of 4 is a 2. We're going to multiply our fraction across. 11 is the whole number, 11 over 1, so we have 77a divided by 2. This is our final answer, 77a over 2. One last look, these do not simplify. Number 5. Start with negative 5. Do we have any perfect squares? I think when these reduce, they will become perfect squares. So another part of the special note is you may have to reduce first. 2 goes into 162 81 times, so 81 on the top. There are 2 more t's in the top. There's nothing in the bottom any longer because the 2 and the t, they cancel out. So this technically is a fraction because it's over 1, but I'm not sure I need to do the square root of the top and the square root of the bottom. Negative 5 times the square root of 81 times the square root of t squared. I could say that divided by the square root of 1, but the 1 is not necessary in the denominator. We don't need that. Negative 5 times 9 times t. So our final answer is negative 45t. Looking at the last exercise, look for perfect squares. You may have to simplify first. 3 over 16 doesn't simplify. M and m to the 5th simplifies. There's a larger power of m in the denominator. Square root, simplify first. 3 16th. There are 4 m's more in the denominator, m to the 4th. What are perfect squares? Anything from our list of numbers and any power with an even exponent. So we're going to simplify the fraction first, and then we're going to simplify our radicals. So we're going to separate the top from the bottom. 16 is a perfect square. M to the 4th is a perfect square. We're going to leave the square root of 3 on the top. We're going to replace the square root of 16 with a 4. We're going to replace the square root of m to the 4th with a m squared, and nothing simplifies. This was part 1 of my video.